morning students, and welcome back once again to another video for the light chapter. And today we'll be doing a little bit of revision starting from the very beginning. We studied about the reflection, that is the incident ray of light falling on a particular surface and bouncing back is known as reflection of light, and at that particular point is called incident point. And from there we can imagine a straight line which is perpendicular to the surface, which is known as normal, and so the incident ray creates an angle of incidence with the normal and the reflected ray creates an angle of reflection with the normal in such a way that angle of incidence and angle of reflection are always equal. Okay, so this is the thing that we studied: incident ray on a surface, reflected ray like this, a perpendicular normal to the surface. This is angle of incidence, this is angle of reflection. Angle of incidence and angle of reflection are always same or equal. Angle of incidence is equal angle of reflection. Okay? Now coming back to our main topic, that is the spherical mirrors. Spherical mirrors are a part of an imaginary sphere. Okay? We have concave mirror like this, where the shiny surface is curved inwards, and we have a convex mirror like this, in which the shiny surface is curved outwards. Okay? This line which passes through the center of the spherical mirror is called principal axis. It is called principal axis. Okay? This one as well. Principal axis. Next one, the center on which the principal axis is incident on the mirror is called pole, given by symbol P. This one also pole, given by symbol P. Okay? And for a concave mirror, the center of curvature is over here in front of the mirror, and for a convex mirror, the center of curvature is behind the shiny surface. Okay? What is this center of curvature? The center of curvature is actually the center of the imaginary sphere, which is the part of which this mirror is a part of. So if you imagine a sphere like this, and imagine a sphere like this, then this center of curvature is the center of that sphere. Okay? So this center of curvature, imagining a sphere like this, and so it is the center of that particular sphere. And therefore, this part is called the radius. Okay? Radius of curvature. Radius of curvature. Okay? So the distance between center of curvature and pole is called radius of curvature. Understood? And there is a point on the principal axis between center of curvature and pole, which is known as point of focus or focus point. Okay? This point is the point where the incident ray of light after reflection meet or seem to meet, because in this case they are actually going to meet, because the concave mirror is a converging mirror and convex mirror is a diverging mirror. So in this case the rays of light actually diverge, so they don't meet. But when we take the reflection behind the mirror virtually, then they seem to meet at a certain point. In this case as well, the focus point is going to be behind the mirror, behind the shiny surface, and once again between center of curvature and pole. So focus point is always going to remain between center of curvature and pole, as you can see in both the cases. Okay? And the distance between focus point and pole is called focal length. So I am going to make a bracket over here. This is called focal length. The same thing is over here as well. From pole to focus, this is focal length and this is radius of curvature, R. Now the interesting thing is that this focal length small f is actually half of the distance of radius of curvature. of curvature is 20 centimeters, then focal length is going to be 10 centimeters. I repeat once again, focal length is half of the distance of radius of curvature. So if radius of curvature is 20 centimeters, then focal length is 10 centimeters. So if radius of curvature is 10, then focal length is 5. Very simple. So you can write like this, that focal length f is equal to r by 2. That focal length f is r by 2. That is half of the radius of curvature. And this is true for both the cases. There are no different formulas for this different mirrors. Okay. Only the image formation will be different, that we are going to study in the next video. And that is why I wanted to revise all the topic once again before getting started. Okay. So now that all of this is clear, now let's revise all the cases that we studied in the previous video once again. Okay. We have a concave mirror and we have a convex mirror. Okay. In this case, the center of curvature is over here, focus point over here. In this case, focus point is here and center of curvature is here. First case, if an incident ray of light is parallel to principal axis. If the incident ray of light is parallel to principal axis, then after incident it will pass through focus. Same thing over here, incident ray of light is parallel to principal axis, so it will diverge like this. But if you take the reflection behind the mirror, it is going to pass through focus like this. The second thing, if it is passing through focus, then the reflected ray of light will become parallel. So if the incident ray of light is passing through focus and then incident on the mirror, then after reflection it will become parallel. So if it is parallel, it passes through focus, and if it passes through focus, then it becomes parallel to principal axis. Same thing over here as well. If you imagine, let's say a ray of light passes through focus like this, then after incident it will reflect and become parallel to the principal axis. It does not mean that the ray of light will be incident only from the bottom. If the ray of light passes like this, then also it will become parallel. Quite simple. Okay. The third case, if it is passing through center of curvature like this, okay, then after reflection it will follow back the same path. So if a ray of light is passing through center of curvature and falling on the mirror, then after reflection it will follow the same path. Same thing over here. If a ray of light is incident like this, then after reflection it will follow back the same path. Okay? It will not deflect, it will not change its path. It will come back on the same path that it came. I hope it is clear to you, students. And the last one, if a ray of light is incident on pole, then after reflection it will create angle of incident and angle of reflection, where the principal axis will act as a normal. Okay, so it will reflect at the same angle it was incident. Okay, so it will reflect back at the same angle it was incident. Same thing if in the convex mirror as well. If it is incident on pole, then after reflection it will depart at the same angle from which it was incident. So that's all for today, students. Once again, this revision video might be helpful to you, and I will talk to you in the next one with a lot of different image formations.